Bear demo with. So if you heat a metallic chlorate, you're going to get the metal chloride. So the metal chloride plus oxygen. So we'll need a 3 here to balance it. And again, on the left side, there's only one compound. That's how you know it's decomposition, because you only see one thing. Can I erase this?
Yeah.
Type 4, you got 3 more to go. If you look at Appendix C, it says, what happens when you heat a metallic nitrate? If you heat a metal nitrate, you get the metal nitrate, you get the nitrite plus oxygen. So let's see here. If you heat, how about if you heat the nitrate, you get the metallic nitrite. Write the charges, balance it, I'll need a 2 there. And I will get oxygen. Erase the charges, and it's balanced, isn't it? Nice. Type 5. Acids. When you heat acids, they decompose into water. So if we take, and this gets tricky. Let's see. When you heat an acid, you get out water. So I recommend you write the water first. And then what's left? What didn't we use up? Sulfur. And how many oxygens didn't we use? 3. So it'll be SO3. So you just look at whatever you didn't use up, that's what's left over. So it should all be balanced, and it is. Type 6, oxides when they heat. And this is one way for getting pure metals. Suppose you take, this isn't the only way you can do it, but suppose you dig up aluminum oxide out of the ground. Most metals are not found in their pure form. Okay, only very few metals like gold, silver, copper, nickel, do you dig them up and they're in their pure form. A lot of other metals are combined with something else. If you heat it, you can get the metal by itself, and oxygen will be released. and then you can get the pure metal. So what are we gonna need to balance this here? 2 there. I've got 3 oxygens here, I'll need a 3 there, that gives me 6. So then I'll have to put a 2 there, and now I've got 4 aluminum, so I gotta go back and change that to a 4. Now, sometimes, and Appendix E gives an example of this, it won't give you the pure metal. It'll get close, but not quite. It's called incomplete decomposition. And the example they give you is lead. If you heat lead, you've got lead 4. If you heat it, it could give you lead 2 oxide plus oxygen. And then you balance it. If you want to get lead by itself, then you have to heat this, the lead 2 oxide, and really heat the heck out of it, and then you can get lead by itself. So this is called incomplete decomposition, that's complete decomposition. And then the last one, type 7, and then you've survived, is electricity. For some things, if you zap it with electricity, it'll break apart. And didn't I demo this for you this year already? Where we took water and we broke it apart with electricity. So if you run electricity through water, you will get out what? Hydrogen and oxygen. All it does is break it apart. If you zap electricity, it breaks it apart. However, what do we know about hydrogen? Diatomic. Oxygen, diatomic. So we'll need a 2 there and a 2 there. So let's do a couple examples and I'll give you some time to work. And again, in the beginning here, it's going to be tough, Tristan, and then after a while, you get okay at it. Right, Wukash? Let me get, here we go. The front side's a little bit easier than the back side. And for homework, we're just going to do the front side. So as you can see, now you're going to have to predict the products. I've still written the reactants for you. And then on the back side, it gets harder because how did I write the reactants on the backside? As words, okay? But we won't do the backside for homework, Danny, just the front side, okay? And the number out front tells you the number of products. So when I look at number 3, there's a little 2 there. So that tells me there are going to be 2 products. And then I have to try to figure out which type it is. So when I see this, I see a single displacement. So I'm going to end up with hydrogen, which is diatomic, and zinc, which is a +2, chlorine's a -1. Put a 2 there, erase my charges, 2 chlorines there, put a 2 there, and now the reaction is balanced. Anytime you see the word heat, it's going to be a decomposition. Plus, you can tell there's only one compound on the left side. So, decomposition, 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 decomposition.
How else can you tell?
The only way you can tell is if there's only one substance. So, like, that's it. There's nothing else for it to react with. All right. So I will put the answer key up front here, but I'll come around and help you guys. Use a pencil. And what do you do if you can't get the reaction to balance? Cry. No. Go back and check the formulas, because they're probably incorrect. Okay? So this is Mr. Strauss's Chemistry Corner signing off. Dobranoc, guten Sieben, and namaskarat.